In this video, we're going to take a look at how to find proportionality equations. So, first of all, if we say something is directly proportional to another variable, then it means that they're going up by the same proportion each time. So, first of all, take a look at this table in front of you. We've got distance traveled by a cyclist, and we've got the number of revolutions of the wheels of the bike. Okay, so for example, if the bike travels 18 meters, that wheel revolves 10 times. If it travels 36 meters, it revolves 20 times. And if something is directly proportional like this, then there is a formula linking the two different variables, okay? So in this case, we're going to define the distance traveled to be d and the number of revolutions as n. So that formula that links the two things is going to be d equals some number, and we call that number k. Perhaps we can find out some examples later of those k values, n. And it's always the same. The k is a number we don't know yet, but d is always equal to n times k. Okay. Now, final thing to just say is that the k is referred to as the constant of proportionality. And if we say things are directly proportional, we'll say that that distance, and that's the proportionality symbol there, looks like a little fish, okay, proportional to n, okay, d is proportional to n. So don't be comfortable and familiar with that notation. Let's jump in and do some examples. Okay, so let's take a look at this table. We have two values, or two variables, x and y, and it says y is directly proportional to x. So that means, let's write it out, y is proportional to x, and that means that there is a formula linking the two, and that formula looks like this. Y equals the constant of proportionality, x. And remember, this is just a number we don't know yet. Let's see if we can find it. Okay, so we know that the formula looks like this because it's stated in the question that y and x are directly proportional. So we've got some information in our table, though. We know that when x is 3, y is 15. So maybe we can use this to help us work out what that k value is going to be. Let's put the numbers in. We know that if we replace the y with a 15 and we replace the x with a 3, that formula holds true. We can use that to work out k. By dividing both sides by 3, we can see that k is going to have to be 5. So that means now we can update our proportionality equation and say that y is equal to 5x. There we are. And does that work? Of course it does. Look, if I have x is 3, so 3 times 5 makes me that 15. So now we know that equation. Let's see if we can fill out the rest of the table, because the first one we've got to work out is when x is 6. So y equals 5 times 6. Well, y is going to be 30. What about when x is 8? Well, y is equal to 5 times 8. Well, that's going to give us an answer of 40. Now, the final two values in the table are a little bit different because we're given y and have to work out x. So let's imagine that we have 80 as our y value. Well, we know it's 5x. So if we now divide through by 5, we're going to get our value for x. X is going to be 16. Again, if we know that y is 120, well, 120 must be 5 lots of x. So if I do 120 and divide that by 5, I'm going to get my value of x, which is 24, and we're finished. So it's all about trying to find this equation first and then using it. Let's jump into another example and see if we can use that same technique here. So the age of a certain species of tree is directly proportional to the diameter of its trunk. Now already, let's just stop there and say that A is going to be the age of a tree, okay, and D is going to be the diameter. Now, if those two things are proportional to one another, then that means that we could say that A is equal to some number D, right? In other words, A and D are directly proportional. Okay, now let's read this information very carefully. So a 4-year-old tree, so when A is equal to 4, has a diameter of 12 meters. So D is equal to 12. So we know that this is true at a set time. So let's sub those numbers into that formula we worked out and see if we can work out what the constant of proportionality K is. So 4 is equal to K times 12. So if we divide through by 12, we're going to have our answer for K. So K is going to be 4 over 12, which is a third. All right. Now, once we've worked that out, we can then rewrite our equation. A is equal to a third of D. Okay. Right, so now we've got our answer to A already. Find the relationship between the age and the trunk diameter. Let's see, and we've got that. That age is a third of the trunk diameter. Let's see if we can work out part B. So find the age of the tree if the trunk diameter is 276. So A is equal to a third times 276. So you could just do that on a calculator or just divide 276 by 3. And so that age is going to be 92, right? 92 years. What about part C? Find the trunk diameter if the tree is 50 years old. So this time we know the A value, the age, but not the diameter. So we'll say 50 equals a third times the diameter. And we just have to rearrange this equation. So to get rid of that third, we perhaps could times both sides by 3. So if I times both sides by 3, I'm going to have 150 is equal to D, and I've got my answer. 150 millimeters. Okay, let's do one final example, and hopefully then you can do the question set. So a bicycle has wheels with a radius of 30 centimeters. The distance D traveled by the bicycle is proportional to the number of revolutions. Right, so straight away, let's just write this down. Okay, so the distance traveled, D, is proportional to the number of revolutions, and we'll call that N, okay? So D is equal to Kn. All right, okay, now we need to now work out some information about this, right? We've got our general formula, right? So a bicycle has wheels with a radius of 30. So if the radius is 30, then the circumference of the bike is 30 times 2 times pi, or in other words, 60 pi. And I'm getting this from the fact that the circumference is 2 pi r. Right, okay, so that is the circumference all the way around, okay? So that 60 pi is the distance covered in one revolution. Okay, distance covered in one revolution. So let's now think about that in terms of our proportionality equation. Okay, the distance would be 60 pi equal to K times 1. Well, if I wanted to work out what K is, I need to divide both sides by 1, in fact. So, of course, K is just 60 pi. So our formula then is going to be that the distance is 60 pi multiplied by the number of revolutions. Okay, so let's see now if we can answer part B. How far would the bike travel if it completed 80 revolutions? So what we're going to need to do here is we're going to work out 60 pi times 80. So if we jump on a calculator and type in 60 times pi times 80, we're going to have our answer, and that is going to be 15,072 centimeters. Now, we're probably better off converting that into meters. Well, that's going to be 150.72 meters. Maybe we'll round that to 151 meters. How many times would the wheels go round if the bike traveled 2 kilometers? So 2 kilometers is equivalent to 2,000 meters, which is equivalent to 200,000 centimeters. So this is our distance travelled. We're going to have to rearrange our equation successfully. So we're going to do 200,000 equals 60 pi times the number of revolutions. So what we're going to need to do is to work out our 200,000 divided by 60, or divided by 60 pi, I should say. And that's going to give us our answer. That is going to be 1,061 revolutions. Okay, that last example, very tricky. Hopefully you understood what that was all about and you can access that question.